Okay, so gender pay gap. First off, asked to calculate the average percentage pay gap. For this, you are going to need your copy of the data sheet. So the pay gap is your first column. So paper. First off, we're going to need the average of this. And if we basically just delete all of that, because that's from a previous question. Okay, if we're looking just at the gender pay gap, we've only got one variable here, rather than the two if we were looking at male and female. 33, 30, 29, 27, 17, and minus 16. So hopefully we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That bodes well. We've got a calculator, it's one variable. We are looking to work out the average. So the average is 23%. And effectively the way we would have calculated the average is knowing that the total of x divided by the number there were. So that was 345 divided by 15, and that gave us 23%. From here, we are then moving on to the standard deviation for the percentage pay gap. So that is sigma x so the standard deviation is 16.2. Okay, next we are asked to plot a scatter diagram. Now hopefully everybody can do that. Then we've got things like the correlation coefficient between males and females. So this correlation coefficient, we also need an equation of regression, and we then need to know about what it actually does. So first off, you're going to have to put in the same data that you plotted on your graph into your calculator. We've now got two variables, so we've got women in our first column because they are our x, and x comes before y. 27.5, 35, 12, 20.5, 24.5. That was not 2.5, that was 20.5. And then say 15, 35, 13. Because these two variables each apply to each point, you need to make sure that they are matched up properly, because unfortunately you can't just, if you've missed one out, stick it on the end. 49.50. 16. Okay, so things that we need to know. We have two variables. So correlation coefficient, that's your regression. We use x because it's going to be a straight line, and because we tend to write equations as y equals mx plus c, we'll take the first one. So correlation coefficient is r. So we've got that r equals 0.921, which is really, really high. Then our equation of our regression line, on the calculator it says it's ax plus b, so when we write it we've got to take the a value, which is 1.21, x plus your b value, which is 1.96. So in context, in maths, this is the gradient. So in context, we need to think about what it is. So as the hourly rate for females increases by £1. So that's basically what's on the x-axis and its unit. Hourly rate for males, which is what's on your y-axis. Which is your unit for the gradient. So you've got what's on the y-axis and its unit, what's on the x-axis and its unit, what's on the y-axis and the gradient. So question 7, we are looking at football. No, we're not. That's something completely different. Okay, female hourly pay will be if the male hourly pay is 27. So we know that the male hourly pay is 27. We know from our own equation that y equals, so 27 equals 1.21 plus 1.96. So rearranging that, we take that over that side and then divide by this. If fiddling around with algebra is not your thing, you can also do that in a graph. So you'd have 1.21 x plus 1.96. I draw that. Delete that. So view window, we'd want x to go from 0 up until it's not going to be more than £50. Y, take it up to 30. So you've got your straight line. Then if you want to know what it is when y is 27, you're calculating x when y is 27. So x should come in at 20.69, and because it's in money it makes sense to do 2 decimal points.